In this video, I will show you how to use t-test and ANOVA for experimental design analysis. Okay, let's first load the required packages. So here are the packages we required for today's analysis. So let's run the code. And here we will try to disable any scientific notations that appear in our analysis, just for easier interpretation. All right, now let's open our data file. If you have successfully loaded the data file, you will see the number of the observations and the number of the variables or columns. Now let's check the column names of our dataset. So the first column is customer ID. The next one is products, discount, conversions, advertisement, image, innovativeness, broadness, and involve. Let's summarize some basics statistics of each variables. Okay, so we have a few variables, but let's focus on the three main independent variables in this analysis. The first one is the products. We have two levels, 0 and 1. Discount, we also have two levels, 0 and 1. And for the advertisements, we have three levels, 0, 1, and 2. Now let's view the data set itself. Good. Before doing t-test or ANOVA, we need to pre-process the data a little bit. Our data is only possible for t-test or ANOVA if the independent variable is categorical or factor with different levels. We can check if the columns advertisement, discount, and products are categorical or factor variable yet by using function is.factor, and we just call the name of the column we want to check. In this case, it should be the advertisement. And the computer say false. It means the data is not categorical yet. And let's do the same for other two columns, discount. And products. The computer also say false. It means all these three columns are numerical rather than categorical. And we can convert these variables to factor type or categorical type by using the function factor. Let's run the code. And let's check if we are already successful with the conversion by using again the function is.factor again. Now these three variables already are factor or categorical and ready for the analysis. We need to create a new data frame that combines the existing data, excluding all numerical values, and adding the three new variables we just created. Okay, so first we can add the three new variables we just created right here to here. So the first one is add, the second one is this, and the last one is broad. And we should exclude all the numerical variables for the three IVs. Okay, we can open the data set and check where they are. So the first one is the second column, the third column, and the fifth column. So basically we can specify here 2, 3, and 5. And let's run the code. Now we can check the new data frame we just created with three new factor or categorical variables. So that's good. Now let's start with the independent t-test. So In 1A, we will test whether there is significant difference in the brand image between two different types of products. And we use the site package. And if you want to check the documentation, just question mark, and you will see the documentation about this package. In particular, we will use this package to describe some statistics by groups. All right. So right here, I will try to specify the dataset name, which is ABC, right? And here we want to tell the program to group the data by products. So which should be product. And here we will compute the mean value of the dependent variable, which is image, and standard deviation of image. Right. So we see we have two groups, 0 and 1, and for each group, we will see the number of the observation, the mean score of the dependent variable, which is the brand image, and the standard deviation of the image. Now we are ready to run the t-test for image based on the product. So in the first blank, we need to specify the relationship between the DV and IV. DV here is image, and then the student sign, and the IV is product, and the dataset name is ABC. All right, so here's the result of t-test. So let's analyze the t-test result a little bit. Here, I put all the notes here for your preference. So first, you need to understand what is the null hypothesis, H0 in t-test. So H0 says there's no difference in the average score of product 0 and product 1. Basically, two products are the same for the brand image. And second, you also need to understand the alternative hypothesis, H1. H1 says there's a difference in the means between product 0 and product 1. Basically, two products are different in terms of brand image. And here we have the t-value. So t-value indicates the standardized difference between the means of the two groups. And the negative sign here shows that the mean of product 0 is lower than the mean of product 1. And we have the b-value. So generally, the b-value will tell us if the difference between two groups is significant or not. And right here, we have very small value, so we can reject the null hypothesis, meaning we are confident that there's a real difference between the two groups. All right. And we also have the 95 confident intervals. This shows the range where we believe the true difference in average lies. Since the entire range is negative, it confirms that the product 0 average score is lower than product 1's average score. And importantly, we see the value 0 is not within this range, meaning the difference between the two groups is not 0. And of course, we have the sample statistic. We have the group 0 mean 2.75 and group 1 mean 4.09. Another way is we can confirm the t-test result by buckplot. Let's run the ggplot function. And here we can see the mean score in terms of brand image is quite different. Compare group 0 and group 1 in terms of product. In 1B, we will test if there is significant difference in conversion between the products. So it means products still be the IV and conversion is the DV. So we will calculate the mean and standard deviation of conversion for each product group. Right here, we need to specify the dataset name, which is ABC, and we will group the data by the product, which is brought. We need to compute the mean value of the conversion for each group. And right here is the standard deviation of the conversion. And let's run the code. All right, again, we see two groups with different mean score in terms of conversion. And let's run the t-test for conversion based on the product. You should try to interpret the result by yourself if you look at this t-test result. In 1C, we will test if there's significant difference in image between this count. So this count will be the IV and image still be DV. Again, we can calculate the mean and standard deviation of the image for each discount. Right here, we only need to group the dataset by discount. So we see the number of observation, we see the mean in terms of image for each discount type and the standard deviation of the image. And of course, we can run the t-test for image based on the discount type. So right here, we should specify the independent variable, which is discount. So here's the p-value. P-value is 0.1044, which is not significant as 0.05 level. In 1D, we will test if there's significant difference in conversion between discounts. We can calculate the mean and standard deviation of conversion for each discount. So we just run it after we specify the dependent variable here in the model, which is the conversion. And we are ready to run a t-test between conversion and the discount. All right, good. Now I will show you one way to summarize the result. I will create a new variable called relationship, where I store the direction of each relationship. And the second column I call it p-value, where I extracted p-value from the 4 t-tests we just run above. And then we will view the data. Let's run the code. And you will see something like this one, right? The direction of the relationship and their p-values. So you can accept or reject the hypothesis based on these p-value. Great. Now let's move on to the ANOVA analysis. So among the 3 independent variable product, discount, and advertisements, we have 3 groups: no ad with 0 value, add 1 with value 1, and add 2 with value of 2. In 2A, we will check the effect of different ads on the image. So the IV is advertisement and the DV is image. We will use one-way ANOVA because we only have one single independent variable in this case. And in this case, it is quite useful to answer for the research question: does the advertisement strategy influence the image rating or the brand image? Okay, so let's run the ANOVA. We will store the ANOVA result in a variable called ANOV image. And right here, we need to specify the relationship between dependent variable and independent variable. The independent variable right here is add. Right. So right here, we see the significant result. Good. We can claim that the advertisement strategy will influence the brand image. But how is the variability between the groups? Because we have 3 groups, right? We need to do some further extra steps to know this. And before that, let's discuss how we interpret this ANOVA table. So right here, you will see the ad, which is our treatment variable advertisements. You see residuals. Residuals are the parts of the data that can't be explained by the treatment variable advertisements. Right here, we have the degrees of freedom. This indicates the number of the levels of the IV So the IV have 3 level, -1 is 2, so we have degree of freedom is 2. And 119 residual degrees of freedom suggest there are 122 total observations. 122 come from 2 plus 119 plus 1 equal to 122, accounting for all groups and data points. Good. We have sum of square. Sum of square measure the total variation in the data, and the total variation in the data come from two sources, the treatment variable and the residuals. We have the mean square. Mean square is the average variation. It is calculated by dividing the sum of square by the degree of freedom. And we have the F value. The F value tells us how big the effect of the treatment variable, which is advertisements, is compared to the random chance. And F is calculated by the mean square of the advertisement to the mean square of the residual. And the higher F indicates a more significant effect is this. And of course, we have the p-value, which is significant here. So generally, the p-value in F-test show the probability of observing the F-value if the null hypothesis is true. What is null hypothesis? The null hypothesis here is if there was actually no real differences between the ads. And the p-value here is very small, so we can indicate that different ads lead to significantly different results in terms of brand image. Right. Next, let's compute the mean and standard deviation for image with different ads. So right here, we need to group the data by advertisements, and let's run it. Good. Remember, from the ANOVA table, we know that the result is significant, but we have no idea which group is different from which group. That's why we need to do an extra steps that called pairwise comparison. And for pairwise comparison, we have some methods to do it. Right here, I use the two-key method because the sample size for each group is quite similar to each other. And to do pairwise comparison using two-key method, I will specify the ANOVA model, which is ANOVA image. Right here. Let's run the code. All right, so now we have the pairwise comparison table. We need to understand what does it mean. So the first column, that is the comparison, group 1 versus group 0, group 2 versus group 0, group 2 versus group 1. And we have the mean score difference between two groups in each pair. We have the lower bound, upper bounds represent the range within which we are 95% confident the true difference between the two groups. And we also have the b-value. If you see the 0 is not within the range of lower bound, upper bound, it means that the difference is statistically significant. Okay, so in this case, which pair is significantly different? We can see the last pair. 2 and 1 is significant, and 95% confident interval shows that the difference is positive. There's no 0 within the range. It means the mean score of group 2 is higher than the mean score of group 1. In 2B, we will check the potential interaction effect between ads and products on the image. So basically, we have two IV, advertisement and products. The DV is still the image. In this case, we need to use two-way ANOVA because we have two independent variables. And we can use this one to answer to the research question. For instance, does the impact of advertisement on the image rating change around different products? And for two-way ANOVA, most of the time people are interested in investigating the interaction effect of two independent variables. What is interaction effect? This effect occurs when the effect of one independent variable on the dependent variable change, depending on the level of another independent variable. Let's run the ANOVA model. Here, we need to specify all the IV. So the first IV, we have a advertisement. The second IV is product and their interaction effect. Let's run the two-way ANOVA models. Great. So in this result, we see the main effect of advertisement on the image is significant. The main effect of product on the image is significant, but the interaction effect is not. Next, let's compute the mean and standard deviation for image for different product with different ads. Let's run the code. So we see we have 6 pairs of product and advertisements. The number of observation, the mean score in terms of image, and the standard deviation. Another way around, we can check the result by plotting the interaction effect. Okay, so let's run the code. And right here, we will use ggplot in the x-axis. That is different group of advertisements. On the y-axis, that is the mean score in terms of brand image. And we can color the plot using the product. Great. So usually you should align the plot result and the ANOVA result. So right here you see the advertisements and the product can individually influence the image rating. So for instance, product 1 quite perform well in terms of image rating, right? And for the advertisements, advertisement type 2 perform the best on the image rating. However, their combination or interaction effect is not significant. Why? Why we can claim that? The first thing is the visual impression. You can see the shape of product 1 and product 0 at different level of advertisements is the same, or the patterns is quite parallel between two products. All right. Or we can say the advertisement type influence ratings consistently across both products at 0 level at 1 and at 2. Right. Let's continue into C. We will check the effect of different advertisements on a new dependent variable conversion. Let's run the model right here. We need to specify the dependent variable, which is conversion. All right. And we can compute the mean and standard deviation for conversion with different ads as well. Great. Now let's use two-way ANOVA again. So in this two-way ANOVA, we will check the potential interaction effects between advertisement and products on conversion. We have two IV, ads and products, and the DV is conversion. So we can specify here the DV is conversion. To design, the first IV is add, the second IV is brought, and their interaction term add colon product. Great. So if we look at this ANOVA result, we see the main effect of advertisements on conversion is significant. The main effect of product on conversion is significant and their interaction effect is also significant, right? And of course, we can check their plotting result as well. So let's run the code. So in this time, the plot is quite different, right? If you compare the shape or the patterns between two products, they are almost likely converge or crossing each other. They are not parallel anymore if you look at the previous plot again. So this plot is different. And that is the signal where the interaction effect is significant. So as a marketing manager, you can say product 0 will benefit more from the change in advertisement type from 0 to 1 compared to product 1 from 0 to 1 level of advertisements. In other words, the impact of advertisement type on conversion rating depends on the product. And I also prepare some code for you to check other potential interaction effects. Try it on your own.